Hello. So welcome to today's GFG Potd video. First, to understand the question, and then we see the intention behind it, and then we see the solution. Okay. So the question name is root to leaf path sum. Okay, and we have given a binary tree where every node value is a number, and we have to find the sum of all the numbers that are found from root to leaf path. And the formation of the numbers would be like 10 into parent plus current. Okay, so we are given this and we have to return all the sum from the root to leaf, and like numbers should be formed in this way, that 6 into 10 plus 3, so that becomes 63. 63 into 10 plus 2 becomes 632. So this is the 632. Like in this way we have to form all the remaining numbers. Okay, and after that we have to sum these and return the answer. So let's understand it in whiteboard. So here I taken the same example. Then here, from here the 6 is written. Okay, and from here what we have to return here, we have to return 6 into 10. Okay, 6 into 10, because 6 is the parent that is coming from there. So 6 into 10 plus 3 here, so here it become 63 here comes. And we have to return here what, 63 into 10 plus 2, because 63 is returning from its parent, that is 3. Okay, so 63 into 10 plus what we have to add, we have to add 2, so it become the 632. Okay, so this becomes 632. We have to return here, from here what we have to return, we have to return 632. Okay, so okay, so this is what we have to do in this question. Okay, so as as we all came from the solution that we have 6, 3 and 5. This is the simple tree I have taken. Okay, so what we are doing here, that we have to give 6 to this 3, and then this 3 what return, this 3 return 6 into 10. 6 into 10. Okay, and 6 into 10 plus 3. So 6 into 10 plus 3, it is written this to this 6. Okay, and then that again we have to go to 5, and then 5 what did 5 did, that is 5 is written here, 6 into 10 plus 5. Okay, so 5 from here written this sum. Okay, so to this sum will be returned to 6. So this is all we have to do. So as you understanding that this is a typical problem of the recursion, because we are returning the sum, taking the sum again and again. Okay, so this is the question. So let's understand the intuition for the bigger tree, that 6, 3, and here they are given 5, here they are given 2, and here they are given again 5. Okay, so as we understand they already, that here it comes 63. Okay, and then it return what, it returns 632. It returns 632, but that same 632 will go here if that will return 632. So instead of this to return 632, we are making here 632, and we store that value in a vector. Okay, we store that value in a vector instead of returning, because returning caused the problem for the 5 one, to take account the complete sum. Okay, so instead of returning this, what we do, we store 632 in the our vector, so that is remain preserved, and instead of 632 what we return, we only return 63. Okay, so then the question arises that how we can make 632 and 63 from 632. Okay, so what we do that first we subtract our root sum. Okay, so our root, not root sum, root data. So root data is 2, so what it become, it becomes 630. Okay, and then we divide it by 10, so that our again become the same, and then it become again 63 here. Okay, so it becomes 63 here. So then we return the 63 instead of 632. So here also then to 5 instead of 632 comes 63, and what it did, it did 63 into 10, 63 into 10 plus 5. Okay, so what it will be? It will be 635. So it will return 635 from here. Okay, so that all we have to do. And then again the same thing we have to do, like instead of here returning 635, what we are doing, we are subtracting the again we have to remove the 5 from here. and again the same thing we have to do at the 3 also, because instead of returning 63 from the 3, we have to return 6, because the same 6 will go to the 5 also. So that all thing we have to do. So it's a typical problem of the recursion, as you all understanding. So let me like take you to the code, so that you can better understand that what we are doing here. Okay, so this is the code, and this is the store sum that is storing all the sum of the values that we are making, because there is a no root left, root right, then we are making a sum value. So that's all the sum values are storing in this store sum. Okay, and at final we are calculating the sum of all the sum numbers. Okay, and returning our vector, returning our store value y. Okay, so this is the thing that we are doing here. So instead, like if we what we are doing in the call function, in call function we are saying that if there is no root, then we have to return, as you all know. And if there is a root or anything else found, then we are doing that 6x into 10 plus root data, because x is the treating here like a parent. So parent into 10 plus the current we have to do. So the same thing I am doing here, and if I am not finding any root left or root right, then what I am doing, I am storing that value in our vector. Okay, and then calling for left and right, and at the time of the going, what I am doing here, that the same thing that I already said to you, in this. Okay, like the same thing that I already said to you, that this is this is what I am doing here. like uh, 63, I am first subtracting root data, then I dividing by it by 10. Okay, so the same I am doing here, that x is equal to x minus root data, and x is equal to x divided by 10. Okay, so instead of returning complete value, I'm returning only partial value. So that's all. So let me compile and run this solution. Okay, so it is running fine. Let me submit it. I think it's running fine, because I already checked it and find you the best solution that I ever seen on the any platform, or at any the ChatGPT, or at any. So I'm finding it by the best solution, and I'm providing you the best solution. So I think that it is good accepting. Let me see. Okay, so this is the same code. This is the same code, and that is got accepted. Okay, so thank you.